Hey guys, so I figured I'd do a quick video on the CNC controllers electronics that I'm using to control the MDF CNC router here. Now, this unit looks fairly complicated, but it's actually fairly simple in principle, and actually there's a much simpler solution that I'll go over at the end of the video here. What it consists of is a small microcontroller board called an Arduino. It's connected to your computer via USB cable. It, in turn, in my case, is connected to a proto board that I just used for the wiring connections between it and the big easy driver boards. Now these are the stepper motor controller boards. They're rated for about 36 volts maximum, and I believe it's 2 amps per phase. Realistically, you'll get just over an amp, maybe an amp and 1.4 amps total. Now the wiring between the Arduino and the stepper motor controller boards consists of a ground and 6 step and direction control wires. Now there's 1 step and 1 direction control wire for each board for a total of 6 wires there. Now beyond that, the only other connections that you need are the actual connections from the driver boards to the stepper motors and the power connections. Now in this case, I'm using an old laptop power supply to power the step motor driver boards. It's about, I think it's between 22 and 24 volts, about 90 watts. That's probably about the minimum you could get away with for this thing here. But apart from that, you don't really need anything else here. Now, in this box, I've got a little bit more set up. I actually have a relay set up here to turn off the spindle, or actually the original case was to turn the plasma cutter on and off. But in any case, you could use it for the spindle. Not required, but handy to have. Some power indicator lights, which are definitely not required, but handy to have. And some control buttons that will either reset the unit, hold the feed, which is useful if you see it looks like it's going to crash. You can hit that and it'll stop working immediately. And then a cycle start resume if you decide that you want it to resume after you hit the feed hold button. And then of course an e-stop switch. Now, of all that stuff, the only thing you really require is the Arduino board and the driver boards, but there's a much easier way to go than this, where you don't actually have to do anything but the most minimum of wiring. What I've got here is I've got an Arduino. Now, the software that I've got loaded on here, I should have probably covered this earlier, but the software I've got loaded on here is called GRBL. And what that does is that takes G code and changes it into step and direction control signals for the stepper motor controllers. Now, I've got here what's called a GRBL shield, made by synthetos.com there. And what it does is it takes all 3 of those boards and basically combines them into one unit. Now, it's not exactly the same chipset, but I believe the ratings are approximately the same. This one here will take up to a maximum of 30 volts, and I believe it does 2 amps per channel, but I'd have to check the specs on it. But what the advantage of buying this board is that it eliminates all the interconnect wiring between that and the step motor drivers, because this literally just plugs into the top of the Arduino board, and from that point all you need to do is wire up your power and your 3 stepper motor wires, and you've got the minimum CNC controller configuration that you would require. Now, personally, I would recommend that in addition to that, you wire up these 3 buttons, and you always have an e-stop. Now, in this case, the e-stop literally kills the power to everything inside this box. So the same thing would be what I'd expect to see for this sort of a situation here, is that you cut power to the step motor controller so that if it is crashing, it doesn't at least go any further than it has already. Now, what I'm showing here is an alternative to a laptop power supply, because laptop power supplies aren't too hard to get a hold of, but getting one that has the sufficient power that you need is a little bit harder. This one wouldn't be suitable for this unit because it's too high voltage. This one is rated for 36 volts, and these boards are rated for maximum of 30 volts. But if you look on eBay, you can find these exact power supplies in a variety of voltages and current ratings. If you got, 9 or 10 amp unit that was under 30 volts, you'd be more than fine. Like 25 volt or 26 volt in that range would probably be absolutely perfect. So you could have an entire setup, like this entire setup here cost, I believe this board was $60. One of these boards you can get them for as little as $20 or $30, and this power supply is about $50. So for probably around just over $100 you would have this CNC controller that you required. Now of course you have to put a case around it. You still have to buy your stepper motors, but those are fairly readily available. Now I believe most of these parts, except for that power supply, are available from a company called SparkFun. These are, I believe it's 125 inch rated stepper motors, 200 steps per revolution. I believe they also sell these GRBL shields, and they obviously, I'll guarantee you that they sell these Duemel Novas. Now there's no great advantage of this setup over that setup, other than the fact that if I blow up an individual driver here, I can replace it, whereas in this case that board, you know, would be pretty much useless. That doesn't happen too often, but you do have to be careful about it. These drivers here, and I assume the same is true for these drivers, if you disconnect the step motors while the power is applied, you'll blow up the board. And I have done that, where a connector popped out of the back of the unit and destroyed a board for me. So you can avoid that just by screwing your connectors in, which I hadn't at the time. In any case, I think that covers it all. If you check out GRBL on the GitHub website, that's where you get the code from for the Arduino for the CNC controller. They also have connection diagrams and all that, so to give you all of the locations for the switches. And you can also decide if you want to add LEDs, which you need to current limit with a resistor. But apart from that, it's pretty straightforward. This box was just a box I had lying around. It was an older hard drive enclosure. Just to complicate the situation, I'm using one power supply for the stepper motor drivers and the internal power supply, the original power supply in here, to power the Arduino. The only reason I did that was for a little bit of noise isolation between the power supplies. Because of the way that they set these boards up, they actually have an onboard 5-volt regulator that you can use to power the Arduino, so you don't actually need that separate power supply. And in this case, you automatically get that because that's the way they set up these drivers. It's worth pointing out, just as an afterthought here, that the Arduino board and the DRB shield that's actually wrapped up in here are static sensitive, so standard static precautions are worthwhile taking, which means usually wearing a strap, a grounded strap on your wrist, or making sure that you discharge yourself to a ground source. In a lot of cases that's the metal case of a computer or that sort of a thing, if it's plugged in. In any case, just something of note. Anyways guys, hopefully that information was useful. If you have any questions, you can always just post them in the comments or send me a PM on it. I'm not an expert in this. This is about the third or the fourth CNC machine I've actually ever built, but this is probably the best working one so far. Regardless, I'll talk to you guys later, and thanks for watching.